Hello friends, welcome to this video on Chebyshev's inequality part 4. We have been applying Chebyshev's inequality to find the lower bound or the upper bound of any given problem whose actual probability function is not known. The problem is a random variable is exponentially distributed with parameter 1. We have to use Chebyshev's inequality to show that the probability of minus 1 less than x less than 3 is greater than or equal to 3 by 4. We can also use it to compare with the actual probability. So the question as such comprises of two parts: finding the approximate value using the Chebyshev's and finding the actuals using the given distribution. So we will try to first compute the approximate values using Chebyshev's inequality. We have two formats of Chebyshev's inequality. We will have to see which one suits much closer or which is going to be more appropriate for the given problem. So what are the two formats? So the two formats are probability of x minus mu greater than or equal to k sigma, and the other one is probability of x minus mu less than or equal to k sigma. What we have in the problem is the probability of less than or equal to quantity. Over here, the probability of over here is greater than quantity. Over here, the probability of going to be equal to less than quantity. So this suits much better than the other one. So we are going to opt for the second inequality. So we have probability of modulus of x minus mu less than or equal to k sigma to be greater than or equal to 1 minus 1 by k square. Now the unknown quantities are mu and sigma. How to estimate them? We'll have to make use of the given data. What is the given data? We have been said that x follows exponential distribution. What is our exponential distribution? F of x is lambda e power minus lambda x, valid for x greater than or equal to 0. For our exponential distribution, lambda is represented as the parameter. And if so, what is the mean of the exponential distribution? It is given by 1 by lambda, and variance is given by 1 by lambda square. So now the data says parameter is 1. So lambda is 1. So parameter lambda is 1 gives the value of mean to be equal to 1 by 1. So 1. And the value of variance is going to be also 1 by 1 square, which is 1. Hence, I have mu to be equal to 1 and sigma square to be equal to 1. Now, apply these two quantity to the Chebyshev inequality. So, we have probability of x minus mu is 1 is less than or equal to k times of what is sigma? Sigma is going to also be equal to 1. This is greater than or equal to 1 minus 1 by k square. Now, how to consider this less than or equal to of a modulus? Consider the negative value of 1. So, it is minus k less than or equal to x minus 1 less than or equal to k is greater than or equal to 1 minus 1 by k square. Now, balance this minus 1 to both sides. So, you get minus k plus 1 less than or equal to x less than or equal to k plus 1 is greater than or equal to 1 minus 1 by k square. So, we have probability of minus k plus 1 less than or equal to x less than or equal to k plus 1 to be greater than or equal to 1 minus 1 by k square. What is the question requires us to find probability of minus 1 less than or equal to x less than or equal to 3. Probability of minus 1 less than or equal to x less than or equal to 3. Now compare it with the given part. So on comparison, what do we have? We have 3 to be equal to k plus 1 Or we can compare the left hand side and say minus k plus 1 is minus 1. Both of them will give you the same value for k. So let me compare the right hand side, which says 3 is equal to k plus 1. So what will be the value of k? K will be 3 minus 1. So k takes the value 2. When we go and substitute it over here, by the Tchebychev inequality, this has to be greater than or equal to 1 minus 1 by 2 square. So that is 1 minus 1 by 4. So this leads us to the answer 3 by 4. Hence, we have shown that probability of minus 1 less than x less than 3 is greater than 3 by 4. Is greater than 3 by 4. Using which value? Using Tchebychev's inequality. Now, the first part is over. How about the second part? The second part asks us to compare it with the actual probability. What do you mean by actual probability? So, how can you get your actuals? I want the probability of minus 1 less than or equal to x less than or equal to 3 using my actual probability. We know that x follows what distribution? Exponential distribution, which is going to be an continuous distribution. When it is a continuous distribution, we make use of integration as the operator. Hence, probability of minus 1 less than x less than 3 is integral from minus 1 to 3 f of x dx. So, this is my actual requirement. What do we know about exponential function f of x? It is lambda e power minus lambda x, valid for x greater than or equal to 0. We have been said lambda is 1. So this takes as e to the power of minus 1 times x. So minus x for x greater than or equal to 0. We will have to be cautious that the exponential function starts only with 0. But what is required over here? It is from minus 1 to 3. So let me split and write this as minus 1 to 0 f of x dx plus integral from 0 to 3 f of x dx. What happens in the range x less than 0? The function is going to take 0 elsewhere. Hence, this function between minus 1 to 0 will vanish for the exponential function. So, we will have to just integrate between 0 to 3. What is our f of x? E power minus x dx. Integration of e power minus x gives you e power minus x by minus 1 between the limits 3 to 0. Now apply the upper limit. So you have e power minus 3 divided by minus 1. Upper limit minus the lower limit. Minus of minus will become plus. E to the power of 0, which is going to be 1. So I have 1 minus e power minus 3. Now use your calculators to estimate the value of e power minus 3 and then you can subtract it from 1. The answer for which you will be obtaining it as 0.9502. So probability of minus 1 less than or equal to x less than or equal to 3 using your actuals is 0.9502. And what was it using your Tchebychev's? The Tchebychev's gave you the answer as probability of minus 1 less than x less than 3 to be greater than or equal to 3 by 4. What is 3 by 4? 0.75. So for your Tchebychev, the answer is 0.75 and for the actuals, the answer is 0.9502, which is more or less in the same range and hence your answers tally with one another. Thank you.